exponential functions, typically there is
They're not those kind of ground.
3 equations that we use. Okay? So we have the equation that we have seen, which is y equals a b to the power of x, right? And then b, I can find it from the ratio. Okay? If it's doubling, it's 2. If it's tripling, it's 3. If the ratio is 0.5, it's 0.5, right? Whatever my ratio is, I plug it into b.
Yeah.
Right? So this is my general form. But sometimes they don't give me the ratio. Okay? Sometimes they tell me that we're growing by a percentage, or we're decaying by a percentage.
Sure.
And that happens a lot, especially when it comes to money, interest rate, right? Or when it comes to bacteria numbers, or when it comes to whatever it is, right? They give me a percentage.
Yeah, go chill in my room.
Now that percentage cannot go right away into the B, okay? Because that's not my ratio. So I have 2 other formulas that are very similar to this, but are specific. We specifically use them for when they give me percentage. Okay? So one of them is y equals 1 plus I to the power of x. And I use this one when I have an exponential growth given a rate. Or a percentage. That's what I read. Okay? So if my money is growing at 10%, okay, that I is my 10%, which is 0.1. And then I add that 0.1 to the y. Okay? So now my base is going to turn into, I'm just going to use that example, 1 plus 0.1 to the power of x, right? And you see that now my base has turned into a b, right? Which is 1.1. Right? Are we okay with that? So that's an example if I'm growing at 10%. Okay? So what I did is I took my 10% and I plugged it in for I. But I can't plug it in for I unless I change it into a decimal. Looking at the equation, my base is greater than 1, correct? So it's an exponential growth. That's a good thing because it says that the money is growing, hopefully. It turns out to be an exponential growth because it's greater than 1. Now what if I have an exponential decay? So the value is decreasing. And given a rate or percentage. The equation is going to turn out to be y equals a 1 minus I to the power of x. So you're going to subtract the rate from it. Okay? So for example, your car value is decreasing by 25% each year. Okay? So what goes into that I?
25%.
Hmm?
Divided by 0.5.
So it's going to be a 1 minus 0.25 to the power of x. Right? And if I do subtract this, that's going to give me 0.75 to the power of x. Now looking at your base? Is your base between 0 and 1, or is your base greater than 1? It's between 0 and 1, right? And that represents decay, right? Because remember we talked about the decay and growth, and we said growth has to be greater than 1, decay has to be between 0 and 1. Okay? So these two equations, we use them when they are giving me a percentage, a rate. Okay? And A value is the initial value. So let's say your initial value of the car is $25,000. Okay? Then you plug $25,000 into A. Your initial value of the car is $15,000. You plug $15,000 in for A, and then the rest will remain the same. Does that make sense to you guys? Now, you're going to see different versions of this equation. So you might see a version that looks like, you don't have to write this, that looks like this, right? They change the letters. Who cares? A is my Y, P is my initial. It's still the same, right? Or you see some equations, they write them A equals A0, 1 plus I to the power of A. Guess what? It's exactly the same. They're written in with different variables, with different letters, because people like to use different letters for different things. But they're exactly the same thing, right? You see this one a lot when it comes to money, right? Because that's your final amount. A, P is your principal. The principal, which is your initial value that you put in the bank, right? Right? So it does not matter how the equation looks, like what letters they use, as long as the equation looks exactly the same with different letters. Right? And this could be a lot of, in the science world, they use this one because this is the final amount, this is the initial amount of A naught, they call it A naught or A0, so that's initially, at time 0. This is how much you have. So please don't get yourself confused if you see the different letters. They mean exactly the same thing. Are we good with that? All right, now we can solve this question. Suppose you have $500 in the bank and you deposit it into a savings account that pays 2% interest per year. Find the equation that models this exponential growth. So because it's growing, what's the formula that I'm going to use?
1 plus
Y equals A, 1 plus I to the power of x. What's my initial value?
500.
500, because that's how much money you put in the bank. I probably should. Yeah. And then 1 plus, what's my rate? 0.02. So it's 500, 1.02 to the power of x. Can I multiply the 500 by the 1.02? Can I multiply the 500 by the 1.02? No. Because the 500 is not to the power of x. Okay? I can't. You have to leave it like this. Please. Please. Okay? Leave it like this. Now, find the amount of money you will have after 3 years. We replace x with 3. Yeah. And then on the calculator, right? Remember that you have to enter it like this, as such, and then you have to make sure that, because BEDMAS tells me I have to do my exponent before I do my multiplication, right? So that's why you have to be careful how you enter it in the calculator. So make sure you enter it properly in the calculator and find me how much money I will have after So 530.60, because money is just two decimal places. Okay? Make sure that, because this is a word problem, make sure you include a therefore statement at the end. Therefore, in 3 years, I will have $530